Okay, hello students. This is the first example video. So making this video, I'm assuming you already went through the slides provided to you. Um, you looked at how to reactivate the old solver in NX. You set the correct role in NX. You created a file, and you also added the view and utility groups as those will be necessary. I will also show how to add the utility group. Um, so adding a utility group and the view group is important. You'll see a bit later. You click on this down arrow and you just click next to the view group and the utility group. You'll see them populating here. They're quite important, especially for showing and hiding certain objects, and then also for changing the shading. That's a bit later for modeling, and also the view for modeling a bit later. Okay, so I'll be showing you how to make example one. Now this may look like quite a complex part, but it's actually very simple, and it is sort of a nonsense part, as it is its sole purpose is to show features of NX. Okay, so first we begin as always with starting a new sketch. You'll see this is the old one. I'll just make a new one. So then I select the plane I want to put the sketch on. So first I see my thing is not showing my datum plane. So I'm just going to go to view group, show and hide, add datums. Yours should show your datums. Then I'm going to click here and just return to home view. Okay, so now we can add a sketch and we want to work on this face. We click OK. Right, so now we're going to begin. I'm going to go through a bunch of these tools that you have in NX. But I'm not exactly going to go in order, but they're all also shown in the slides. So the first one I'm going to use is the rectangle tool. So I'm going to begin. So I hope you have the slides with the reference image open, because there's not enough space to show that on my screen as well. So I'm going to start with the rectangle, which has the half circle on top of it and the other circle inside of it. It has one corner chamfered and the other one rounded. So the rectangle tool, you'll see you have three different options here. I usually just use the first one, so it's by 2 points. So you click one point and you click the other point and you have your rectangle. The other option is by 3 points, so you click one point, you click the other, and then you sort of slide down to create your rectangle. That's another option. And then the third one, which is the coolest, but it's not really necessary, but it is important. You can use this if you know exactly where the center of your rectangle should be. So then you can click there, extend it to the side, and then you can already type in what your width should be. So for this one, I already know my width should be 60 as from the reference image. So I can just type in 60, click enter, and then it's 60 wide. And then it will ask me for the height. And I know the height is 50. Then click that, click enter, and I have my rectangle. And then I can just click and it will double click and it will show it. It didn't now show the way in which this rectangle tool works, because I typed in the values, but it's essentially just like this and like this. So it's kind of cool, but yeah. Okay, so that's the rectangle tool. So now already we have the dimensions we want, and it's also centered around the origin. This is very important. You want as much of your reference dimensions and constraints to be from the origin as possible. Because if you have one dimension constrained to another one, constrained to another one, if you delete a part, then a bunch of your constraints are broken, and then you have to put them in from scratch. So try to keep the origin at the center of your part as much as possible, and try to reference from it as much as possible. Okay, so now that we have this rectangle, I'm going to add the circle. So for the circle tool, you have two options for making a circle. The first is you select your midpoint. I'm first going to show the other one. So it's by 3 points. So it's just as the name suggests. You click one point, you click another point, and then you click your third point to create your circle. For this one, however, we know where we want the middle point of our circle to be, so we can use this option. So we click once again on the sketch origin and then extended it until the edge of the rectangle as shown in the reference sketch, and just uh, the diameter of 50 is correct, but we can just click on that little blue highlighted dot because this will constrain it to be tangent to that the rectangle's edge. So you can click that. Yes, we want it to be on the midpoint. Click that, and it's constrained. You can just close the circle tool, and you can see sketch is fully constrained. Essentially, that means nothing is undefined. Everything has a dimension or a constraint, such as constraints can be just it must touch this point or be in line with this or whatever, and nothing can move. If I try to move any of this, nothing will happen, and that's good. Okay, so next I'm going to add that little half circle to the top of this rectangle. For that, I will use the arc tool. So for the arc tool, you again have two options. The one is when you know the midpoint, so you click on the midpoint, you go out as far as you want. You can decide the radius and the sweep angle, but you can also just click and sweep it as far as you want. That's the one option. The other one is the one we will use here. You click on the one side, on the other side, and then you can lift it up as far as you want. Here it wants to snap to be tangent to those edges, and that is what we want as well. So we can just click and it will automatically put it in, and that's what we want. So sketch is again fully constrained. Okay, and next we're going to start now with the outside shape. Okay, we will get to the chamfers and rounds a bit later. So for that, we are going to use the profile tool. It's quite useful when you want to create the profile of a part, as the name suggests. So for this one, it's essentially your closely drawing the outline as close as you can to what it should be, and then later you will put in the exact dimensions. So for this, I'm going to be making the outside, so you will see the outside shape is sort of double. I will be creating the outside one, and then the inside one we will create later with another tool. So I'm going to begin here, just left of the box and to the bottom of it, and I'm going to drag to the side. So you will see here I have the line selected, not the arc. So then I go to about here. Then I want to select the arc. So then I arc around like this. That looks about fine. And then I want to arc again to the other side. Yeah, that looks about fine. Now I want to do a line again. So you'll see these are not tangent at the moment, the way I'm doing it, but I would rather make this line horizontal now and make the arc to be tangent later. Because when you start to add constraints, you want certain fixed things, and if everything is wonky, it will cause problems. So I'm going to add this line over here. I'm going to add the one that goes up, one that goes to the side, then the one that goes down over here. Sometimes it will, if you go to this point, there we go. So I went to this point first and I pulled up, and now it wants to keep it in line with that one. So it's about over here somewhere, and then we go back to this one and we close that profile. Yes, I want to constrain to the starting point. So this was an automatic prompt from NX. So I just click that, and now it wants to continue, but I can just close the profile tool as I've created my profile now. So now it's time to actually add the constraints. So first of all, we have this, which is in line with our origin. So sometimes now I want to click on this vector, but it doesn't want to allow me because there's a midpoint constraint. So if you want to click on something but something else is overlapping, you can right click, then you say select from list, and then it gives you an option of things to click. So I want to click on the sketch vertical axis. The z-axis of datum coordinate system, they are the same, so it doesn't really matter, but I'll click sketch vertical axis, and then I'm going to click on the point again. Yes, I want to click on the midpoint. It's just asking because it's not sure, and now it's suggesting constraints to me. Now it has the point on curve constraint. That's the one I want to use. Essentially, it constrains that point to be on the imaginary curve of that vertical vector. So I'll click that and it immediately snaps that point in line. Okay, so that line should also then be 90 wide. So I'm going to double click on that and just type 90. Something I now do also realize is the line is not actually in the center. Um, I misread the sketch. I saw now that there's actually a distance specified from the edge to the midpoint. So to remove a constraint, you can just click on that constraint and click on the X, deleting it. So it's out of the way. So we want to add a distance between this side and this vector. So that's easy. You go either to rapid dimension or to linear dimension. Sometimes NX guesses wrong what you want to do with rapid dimension. So if you know you want to do a linear dimension, just use linear dimension. So you can say it should be inferred, whether it's horizontal, vertical, or so on. Here, I believe it should be quite simple for NX to figure out. So I'm going to leave it on inferred. So I click on my first object, that's the side, and then I click on this vertical axis, and it realized, okay, I want to go horizontally, and then I just click, just put it down. It's on 45, it should be 50, enter, and then it's in place. I can just close the linear dimension option. I'm just going to move these out of the way a bit. Okay, so now I want to change this radius of this curve. So this radius should be 40, not 35. So double click, type in 40, enter, close, done. Next we have this dimension. This should be 25, not 36. So 25, enter, done. And but now I see, okay, it's a bit lower than I want it to be, but I see on the reference sketch that this point and this are in line with one another. So there are two ways of doing it. We can do it the point on curve method we did earlier, or we can select this point and then constrain them to be horizontal with one another. So we can do that, and that's wonderful. Okay, so but we still have auto dimension, so we must continue. Before I continue with this dimension, remember this is not tangent, so you can do a bunch of wacky things. We don't want that, so you can click on the curve. Important with curves, and especially with circles, you see if I hold my mouse here, it's yellow, and that middle point is highlighted. If I hold it a bit here, it's red. So we want it to be red, because if it's yellow, we're going to be selecting the midpoint instead of the curve. We want it red to select the curve, and then we want to select the line, and then we want to select tangent. So then they are tangent to one another. Okay. Then this dimension is 35 millimeters. So we type that in, enter, right. But now we see, now it's messing up a bit because this point is not where it should be. So we can add this dimension real quick. I'm just going to pull the sketch a bit away so that it's not in my way anymore. So this point, I'm going to use rapid animation to show you here. It should infer correctly. So I'm going to use this point. Now it selected the dimension, just cancel, rapid dimensions, point. Okay, sometimes it realizes its error. So let's just say second object and this line. And there we go. It allowed us to create the correct dimension. So this should be 20. There we go. Okay, so next we have this one. This should be 40. Double click again, 40, enter. There we go. Then this should be 70. Same process, just over and over again. This is a bit too low. Let's just move this a little bit up. There we go. Now we need to say, okay, this should be a certain. No, we did not say how high it should be. Okay, so it was constrained from the other dimensions. Okay, so here we can use rapid dimension or we can use angle. So I'm going to use angle here and say this line and this should be 145 degrees. There we go. And now the sketch is fully constrained. Here you can see, so nothing we can do can move anything around. It's all stuck in place. Okay. So that is the majority of the sketch already actually finished, because the rest is going to go very quickly. So, but before we continue, let's first just add that chamfer and that round. Okay, so before I actually continue, let me quickly just talk about the spline tool. So the spline tool is wonderful if you have a picture that you sort of want to trace and then use in NX. For instance, when you get to your airfoils, if you download the profile of an airfoil for your project, and then you can import the picture into NX and then use the spline tool to trace around it. So you can just click points and it will then automatically create a spline. You can choose the degree. So this is essentially a polynomial fit, so the degree to which it fits. So on 1 is straight lines. For 2, it's a second order polynomial, third order, fourth, fifth, sixth. And you see it starts to get wacky when you get too high. So choose one that looks appropriate. Third is usually sufficient. And there's a bunch of other options you can play around with this. But that's the spline tool in summary. Okay, back to the chamfer. So we want to chamfer this edge. Now you get two different types of chamfering. So the chamfer tools over here. You get symmetric and asymmetric. Asymmetric, you either say what the one edge is and what the other edge is, or you say the one edge and the angle. But usually you want to have a symmetric chamfer, so you can just leave it on that. 5 is already correct, the distance of 5 millimeters, and it will automatically trim away the extra material or edge line. So you click the one line, click the other line, and now it wants to do other ones, so you can just put it close, type 5, enter, and there it created your chamfer. You can just close the tool. And now we want to create the round or the fillet. Same difference. So you have different methods. You can use the trim one or the untrim. So the untrim will leave the lines. The trim will remove the lines. The same as here. We want to remove the lines. So we click the one edge, click the other edge, put it where we want it, and just type 10 millimeters, enter, and it added our round. Close that. So we have one auto dimension. So the diameter of this, the constraint broke when we added that. So now we just need to redefine that. You see, that's what happens when you constrain one dimension to another dimension. But that's easy. It's still correct. It's now just not defined explicitly. So it's 50. It's fine. Enter, close, and it's added. For dimensions which are already correct, you can just double click on them and just close it, and it will apply it. But it's always good to just type it in manually to make sure it is correct. Okay, so now we want to add this sort of double layer on the outside. So that is the offset tool. So it's quite a simple tool. So now it's currently set on connected curves. So then it will automatically sort of guess which curves you want to mirror based on what's connected to one another. You can also use single curves. So then, like the name suggests, you have to select each line manually. Use tangent curves. They will select all the curves that are tangent to the one you clicked. And curves in a group, that's also another way. But single curve is nice when you want a bit more control, but for a simple part, connected curves will work fine. So you can just click that, and now it automatically wants to work. But it wants to create the offset to the outside. We want to create the offset to the inside. So you just go here, reverse direction, very simple. Boom, now it goes to the inside. It's already on 5 millimeters. It creates the dimension, and yeah, nothing else needs to change. You can just say OK, and now we have that offset that is defined over here. Okay, so now we just need to mirror the part. To mirror a part, you need to mirror it around a line or a vector or something, something with a length so that you can know which, or a plane, something you can mirror around. You can mirror around a point. So for this, I'm going to add a reference line. So it's just a line I'm going to put in over here. Very simple. Because I don't want auto dimensions, I'm just going to go in here, say it should be 80 arbitrarily. It doesn't really matter. It can be 1 millimeter, and I want it to be that's just according to the reference. It should be 10 millimeters from this one. So I'm going to say linear dimension, this line, then this line, and we want it to be 10 millimeters. Now I sort of moved it up. I don't want that, so I'm going to just say these 2 points, that's just the line with one another. So then, but this is a reference line. I don't want it to show up on my sketch as soon as I go out of it. So you can just hold your mouse over it, it's red, select it, and then here say convert to reference. And then it's a reference line. And now we can mirror, so you can use the mirror tool. Pattern, you will see that in the other other examples. So the mirror tool, you click that, now you select which curves you want to mirror. Here it's just going to be easiest to select everything because you want to mirror everything. So you can just like start at the edge, hold your mouse in and drag a box over everything. Do not select the reference line, and it will select everything. And then select the center line over which to mirror, and you can just select it over there. It will mirror it over there. Just say all right or okay, and then it's finished. Sketch is fully constrained. Click finish. Okay, now once you show it weird, you just click on, it should be at the front view. There we go. And there is the part. We can now just go to show and hide. We can hide our datums. I would also hide our points as well, because it makes the sketch look a bit cluttered. And there you go. That is your entire part. It looks very complex. It's actually quite simple, but I hope it showed you the majority of the functions you can use. So yeah, feel free to try this as well yourself. I highly encourage it so that you can get some practice and see how the different tools work. I encourage you to try doing all the examples yourself. You can follow along with the video because this is how you practice it, and then when you get to class you can then do the homework, and anything you struggle with in this example, you can then come to class and ask me questions or your lecturer questions about this, and you can then figure all that out. But the majority of the work should then already be practiced, so we can easily identify the problem areas. Okay, thank you very much for watching.